What are perfect squares? In this video, you'll learn how to recognize perfect square expressions written in different forms. You'll also learn how to recognize quadratic equations that have a perfect square expression and solve the equation. A perfect square is an expression that results from multiplying a binomial by itself, like x plus 3 times x plus 3. If we were to multiply these, we would distribute the first parenthesis to the second. So we'll break up the first parenthesis and then multiply that by the second. So we'll distribute each term, giving us x squared plus 3x plus 3x plus 9. We'll combine our like terms of 3x and 3x, giving us 6x in the middle. And if we had the expression like x minus 4 times itself, then we would multiply the first parenthesis by the second. So we'll break up that first parenthesis and then distribute it to the second. So we'll get x squared minus 4x plus 16. When we combine the like terms in the middle, we'll get negative 8x. So if we look at both of the expressions that we multiplied and then the answers that we got, we can see that the middle term comes from multiplying our factor by 2, and the constant comes from squaring that factor. So in general, we can write that x plus a squared is equal to x squared plus 2 times ax, and then we'll add a squared to the end. If an equation is in the form x plus a squared equals b, we can solve by taking the square root of each side, so we'll keep that in mind. In this example, we're going to solve the equation by using the factoring method and then the square root method. So let's start with the factoring method. The statement we got from the perfect squares told us that our first term will be x squared, our middle term will be twice our factor, so we'll get negative 12x, and then our last term is found by squaring our factor, so we'll get 36. And then we'll set it equal to 25. Now we want our equation to equal 0, so we can use the factoring method. So we'll subtract the 25 from both sides, giving us x squared minus 12x plus 11 equals 0. So to factor it, we need to find two numbers that multiply to 11 but add to negative 12. Those two numbers would be negative 11 and negative 1. We'll put this on a new slide so we can finish solving it. We'll set each parenthesis equal to 0, and then we'll solve each equation. We'll start by adding 11 to both sides, giving us x equals 11 for our first equation. On the next equation, we'll start by adding 1 to both sides, and this gives us x equals 1. Now we'll use the square root method and see if we still get the same solutions of 11 and 1. So we'll start by taking the square root of each side. This will give us x minus 6 on the left, and we'll get plus or negative 5 on the right. Now we'll set up our two equations, where x minus 6 equals positive 5 and x minus 6 equals negative 5. We'll start by adding 6 to both sides, which gives us x equals 11, and then we'll add 6 on the other equation, giving us x equals 1. So now we can see that we did get the same solutions. Here's another example where we'll try using the factoring method and the square root method. We'll put them side by side so we can see if we get the same solutions at the end. So we'll start on the left with the factoring method. Since this is a perfect square and we want to expand it, our first term will be y squared. Our second term will be our factor times 2, which will be negative 10. And our constant term is found by squaring our factor, so this gives us 25. Now we'll set it equal to 49. We want this to equal 0 though, so we can use the factoring method. So we'll subtract that 49 from both sides, and this gives us y squared minus 10x minus 24 equals 0. So now we'll start factoring it. We need to find two numbers that multiply to negative 24 but add to negative 10. Those two numbers would be negative 12 and positive 2. So now we'll set both of those parentheses equal to 0 and solve. We'll start by adding 12 to both sides. So we get y equals 12, and on the next equation, we'll subtract 2 on each side, and this gives us negative 2. So now we'll use the square root method and see if we get the same solutions of 12 and negative 2. So we'll take the square root of both sides, and this gives us y minus 5 on the left and plus or minus 7 on the right. Now we'll set up our two equations, where y minus 5 equals positive 7 and then y minus 5 equals negative 7. So we'll start by adding 5 to both sides, and this gives us y equals 12. On the next equation, we'll add 5 to both sides again, and this time we get y equals negative 2. And now we can see that our solutions match, so we can decide to use any method, but the square root method usually is easier when we have a perfect square. In this example, we're going to explain why x squared plus 20x plus 100 is considered a perfect square. So let's take the general statement we were given about a perfect square and expanding it. We'll put our equation on the bottom to see if we can line up the terms and find what a is equal to. If we look at our b term, in the first equation it's equal to 2a, and in the bottom equation it's equal to 20. So we can write that 2a is equal to 20. Our constant term in the first equation is a squared, and the constant in the bottom equation is 100. So we can say that a squared is equal to 100. We can solve for a on the first equation by dividing both sides by 2. So we get a is equal to 10. And this makes sense because if we square 10, we get the 100 we got from the constant. So now we know a must have been 10 to give us this perfect square trinomial. Let's find the solutions if the equation is equal to 81. So we'll set this equal to 81 and we'll use the square root method. So we'll take the square root of both sides, and this gives us x plus 10 is equal to positive and negative 9. So we'll set up the two equations where x plus 10 is equal to positive 9 and x plus 10 equals negative 9. We'll solve the equation by subtracting 10 from each side. So we get x equals negative 1, and then we'll subtract 10 from both sides on the other equation, but now we get x is equal to negative 19. So now we have the solutions for this equation. Now we're going to decide which expressions are perfect squares. So for it to be a perfect square, we just need to have the same value in each parenthesis. If we look at the first one, both parentheses say x plus 5. So this is a perfect square. Now let's look at the one below it. We can rewrite negative 9 plus c as c plus negative 9 by just switching the order. If we add a negative, it's the same as subtracting. So now we can see that both of the parentheses are exactly the same. So this is a perfect square. Now let's look at the one below it. We can rewrite y minus 10 as negative 10 plus y, but it still doesn't match the other parenthesis because the signs are opposites. So this one won't be a perfect square. Now let's look at a plus 3 times 3 plus a. They're the same value, they're just switching the order of adding, but we're allowed to do that because of the commutative property. So this is a perfect square. The one below it looks like a perfect square, but one's subtracting and one is adding. So this won't be a perfect square. Now let's look at the one below it. This time the x term are with two totally different numbers. So these aren't equivalent and this won't be a perfect square. In our last example, we're going to solve each equation by using the square root method. So we'll start with our first equation, and we'll take the square root of each side. This will give us x minus 1 equals positive and negative 2. So we'll set up our two equations, one equal to the positive 2 and one equal to the negative 2. We'll solve by adding 1 to both sides. So we get x equals 3, and when we add 1 to both sides of the other equation, we get x equals negative 1. Now let's look at our next equation. We'll take the square root of both sides, and this gives us x plus 5 is equal to positive or negative 9. So we'll set up both of our equations, and we'll solve by subtracting 5 from each side. So we get x equals 4, and we do it to the other equation, we get x equals negative 14. Now let's look at the last one. So we'll take the square root, and we get x minus 7 is equal to positive and negative 8/7. So we'll set up our two equations, and we'll solve by adding 7 to both sides. So we get x is equal to 57 over 7, and when we add 7 to the other equation, we get x is equal to 41 over 7. Now we've solved all of these equations. Let's summarize what we've learned. A perfect square is an expression that is something multiplied by itself. And if we have x plus a squared and we expand it, we'll get x squared plus 2ax plus a squared. We can solve a perfect square equations by taking the square root of both sides of the equal sign.